Hello everyone, this is Chem Bonding tutorial question 11. Question 11 is on physical properties of substances. So this question wants you to explain why the solid listed here have different electrical conductivity and have different mechanical properties. Okay, I think for this kind of question, you follow the same format. First mention what are the structures, then after that the type of bonding, and then your conclusion. Okay, let's have a quick overview of the type of substances. What are the structures? Magnesium, I think it's quite obvious to us that it's a metal. Okay, metal have high electrical conductivity because they have sea of delocalized electrons. They're malleable and ductile. Okay, the second substance is magnesium chloride. Okay, what is the structure? Structure is ionic. So ionic do not conduct electricity in solid state, but conduct electricity in molten state. Okay, and they are brittle. Okay, the third one, phosphorus, P4. Okay, phosphorus is simple molecular. So we know that simple molecular do not conduct electricity and they're soft. And the last one, silicon carbide, SiC, this is a giant molecular. Giant molecular, likewise, also do not conduct electricity because there's no delocalized electrons or ions. Okay, and they're hard because of the big structure, the three-dimensional structure. Okay, so this is how I'll present my answer. Magnesium has a metallic lattice structure. Okay, and because of the delocalized electron, it conducts electricity. It's ductile because of layer ions that can easily slide over each other without breaking the metallic bond. Magnesium chloride, ionic lattice structure, can conduct electricity in molten state because there's a free mobile ions. It cannot conduct electricity in solid state because of the absence of free mobile ions and delocalized electrons. Okay, it's brittle. Brittle because in the ionic lattice structure, the sliding of the layers of ions are not possible. So therefore, unlike metal, which are malleable and ductile, they are not. For phosphorus, simple molecular structure, cannot conduct electricity because of the absence of free mobile ions and delocalized electrons. So take note, wherever we mention why a substance cannot conduct electricity, we have to mention both. No free mobile ions, no delocalized electrons. Okay, it's soft because of the weak IDID. Okay, and the last one, silicon carbide, giant molecular, cannot conduct electricity because of the absence of these two, and is hard because of the strong and extensive covalent bonds between the atoms in a giant 3D structure. Okay, so this question is pretty straightforward. There's a fair bit of memory work. Okay, but important thing is always identify the type of structure, and from the type of structure, deduce the type of bondings, and then followed by your conclusion.